Hello friends, so in today's question, two disks masses m1 and m2 are connected by a spring of force constant k. The lower disk of mass m2 lies on the table and upper disk m1 is vertically above it as in figure. So this is m2 and this m2 m1 and they are connected by a spring which is having a spring constant of k. What vertical force F should be applied to the upper disk so that when force is withdrawn, the lower disk is lifted off the table? So we are going to find out the value of the F such that after the application of force F, as soon as it is removed, the M2 should be lifted above the table. So it should not be connected with the table. So this is the basic question. So first of all, let us consider that the force F is applied such that it compresses the spring by x. Okay. So it means Fs, we can say from this we can say Fs will be equal to spring constant k multiplied by x. Now after the removal of force F, the spring recovers from its compressed length and extends by x in opposite direction. Okay, so basically it means now there is expansion. So we can draw the diagram. So we are going to draw the diagram for two parts. First will be our compressed and the other one will be for the expansion. So we have applied the force F. So this is M1 and this is our M2 and it is connected with the table, and this is our mean position of the original position of the spring mass M1. We can say this is original position of M1. Now it moves by a distance of x in the downward direction when force F is applied to it, and this is having spring constant k. Now if we draw the free body diagram for M1, okay, draw the free body diagram for M1, so we can say force F will be acting in downward direction. There will be M1G rather, also in downward direction, and there will be a force Fs which is equal to Kx in the upward direction. So these are the three forces acting when it is compressed. And similarly we can draw for the expansion also. So as soon as the force is removed, the spring is going to expand and it is going to travel a distance of x in the upward direction also. And this is our M2, which is connected to the which is on the table, and this is our M1. And this is our K. Once again we draw the free body diagram for M2 now. So for M2 we are going to have M2G in the downward direction, and there will be force Fs in the upward direction, which will be given as Kx, and there will be normal because of the table. So this is our free body diagram for M2, and this is for free body diagram for M1. So this is our compressed string, compressed spring, and this is a released, or we can say expanded spring, and this is free body diagram for M1, and this is free body diagram for M2. So for mass M1, you can say F for the mass M1, we can say F plus M1G So for mass M1, F is equal to M1G and Fs, and F is equal to Fs plus M1G. And for mass M2, when the spring is released, so in this case the spring is compressed. Okay, for mass M1, when spring is compressed, and for mass M2, when spring is released, so under this condition Fs will be equal to M2G plus normal. Okay, so this is for mass M2, when spring is released, Fs is equal to M2G plus normal. Now it states that the lower disk should be lifted off the table. So lower disk will be lifted off the table when the normal is equal to 0. So lower disk lower disk, that is M2, will be lifted on the table when normal equals 0. So we can say that our Fs will be equal to M2G, and we already know the equation that F is equal to Fs plus M1G. Substituting the value of Fs, this can be written as M2G plus M1G, and taking G as common, the force will be equal to M1 plus M2. Okay, so it means the lift off will be possible. The lift off for lower disk M2 will be possible for F is equal to greater than equal to M1 plus M2G. So if the applied force is greater than equal to M1 plus M2 multiplied by G, then the lower disk will be lifted off from the table. So this completes the question. Thank you.